Did you know?
Every single piece of matter around you is made of atoms. Atoms are the smallest unit of matter. The atom is divided into the nucleus and the electron shell. The nucleus is the heart of the atom, containing protons and neutrons. The amount of protons determine what element the atom is. For example, 1 proton makes the atom hydrogen, where 92 would make it uranium. Neutrons determine the atom's atomic mass and isotope, which do not affect which element the atom is, but does change its properties. Within the electron shell is the electrons, which has close to no mass and buzz around the nucleus. The outermost shell of the electron is called the valence shell, which determines the charge of the atom depending on how many valence electrons reside in it.
The periodic table is a tool chemists can use for all things chemistry. Each box on the table represents a different element. The column numbers on the far left of the table represents each element's period. The periods are numbered 1 through 7, with 7 having the highest energy level and 1 having the lowest. For example, the energy level of hydrogen is very weak, whereas for uranium it is very powerful. There are many numbers at the top of the periodic table, and they are not to be confused with one another. The numbers labeled 1 through 18 simply represent the column of the table itself. These numbers, however, represent the amount of valence electrons in each column. Valence electrons are the electrons in an element's outermost shell. These numbers represent the charge of each element, which show how many electrons they would like to give or take, which is dependent on the amount of valence electrons. The table is divided into 8 groups: the alkaline metals, alkaline earth metals, transition metals, lanthanides, actinides, metalloids, halogens, and noble gases. The noble gases are, to the elements, the ideal group, having a full shell of valence electrons, leading them to being very unreactive. Due to their lack of reactions, they were the last discovered group of elements. All other atoms want to have a full outer shell, but don't have one.
You'd like me to be you, wouldn't me? But it's too late. You snows. You lows.
This causes reactions to occur. By sharing valence electrons, atoms can bond with one another to create a full outer shell.
Each box on the table represents a different element. The elements are ordered based on their atomic number in the top right corner. The atomic number represents the number of protons in the atom, which, as stated before, determines what element the atom will be. The letter identifies which element it is. Most of the time, the name of the element and its letter are self-explanatory, like H for hydrogen. Other times, it's not so clear-cut, like Hg for mercury or Ag for gold. The number on the bottom represents the atomic mass, indicating its size being the sum of the neutrons and protons. The elements are divided into metals and nonmetals. The metals are defined as any substance that is able to conduct electricity at absolute zero and tend to be solid at room temperature, aside from mercury, but this will be discussed later. Nonmetals are everything that lack these attributes.
Not all elements are created equal, however, some having special traits separating them from the rest. For example, the elements bromine, chlorine, nitrogen, hydrogen, oxygen, and fluorine are diatomic. Brinkelhoff, meaning that they only exist naturally in pairs with each other. The elements bromine and mercury, Br and Hg, are special because they exist in a liquid state in room temperature. The elements on the table get more and more protons the lower you go. Noting that the lower you go, the more powerful the element becomes, many of these elements become too powerful and are unstable. The instability is what causes radiation. Many of the well-known radioactive elements, such as uranium and plutonium, reside in this area of the table. The final general thing to note would be this imaginary arrow present on the table. In this direction, atomic size increases, and in this direction, the electronegativity increases. This has been a very general surface-level explanation of the periodic table. There is indeed more to know about the table.
Did you know we've come up with 6 all-new value combo coupons? And if you sign up for our email club,